Assalamualaikum and good day for you. In this video, we will learn how to draw and explain standard hydrogen electrode, write Nernst equation, and explain the factors that affect cell potential. Standard hydrogen electrode. What is the component of the standard hydrogen electrode? Standard hydrogen electrode is made up of platinum electrode in aqueous 1 molar acidic solution and bubble with hydrogen gas at 180 m and 25 degrees Celsius. The value of standard electrode potential of standard hydrogen electrode is 0 volt, and standard hydrogen electrode can be anode or cathode. Standard hydrogen electrode can be anode or cathode depend on the other half cell connected to it. This is the way half cell notation written when standard hydrogen electrode is anode. It is written on the left of salt bridge. And this is the way half cell notation written when standard hydrogen electrode is cathode. It is written on the right of salt bridge. Let's say we would like to know standard reduction potential of zinc half cell. Zinc reduction potential can be measured by setting up electrochemical cell as shown here. The reading at the voltmeter is positive 0.76 volt, and electron moves from zinc electrode to standard hydrogen electrode. Thus, zinc is anode while standard hydrogen electrode is cathode. This setup must be in standard condition, which is 1 molar, temperature 25 degrees Celsius, and gas pressure at 180 m. This is the cell notation for this setup. At oxidation half cell, zinc atom oxidized to become zinc 2 ion. From reduction half cell, hydrogen ion is reduced to become hydrogen gas at cathode. And this is overall cell reaction equation. Standard cell potential equal to standard reduction potential of cathode minus standard reduction potential of anode. E naught hydrogen is E naught cathode and E naught anode is E naught zinc. Substitute E naught cell with 0.76 volt and E naught hydrogen with 0.00 volt. Standard reduction potential of zinc is minus 0.76 volt. In the second example, a galvanic cell is set up by hydrogen half cell and copper half cell. Because electrons move from hydrogen electrode, it is anode and copper is cathode since electron move into this half cell. The voltmeter reading is positive 0.34 volt. To write half cell notation, it begins with anode and oxidation half cell. Then 2 bars represent salt bridge. After that, reduction half cell, and lastly cathode. This is reaction at anode and cathode. And this is overall cell reaction. From E naught cell equal to E naught cathode minus E naught anode, E naught copper is E naught cathode and E naught hydrogen is E naught anode. Substitute E naught cell with 0.34 and E naught hydrogen with 0.00. Standard reduction potential of copper is positive 0.34 volt. Let's continue with the next learning outcome, which is write Nernst equation for a given galvanic cell and explain the factors that affect cell potential. Standard cell potential for zinc and copper at standard condition 1 molar, 25 degrees Celsius and 180 m is positive 1.10 volt. If these conditions are not met, for example 2 molar concentration or 35 degrees Celsius, cell potential is not positive 1.10 volt anymore. Under these conditions, Nernst equation is used to calculate cell potential. This is Nernst equation, where Q is reaction quotient, T is a temperature, R is a gas constant 8.314 joule per Kelvin per mole, F is a Faraday constant 96,500 coulomb per mole, and N is number of electron swap or transfer in redox reaction equation. Besides it written in terms of log, Nernst equation can also be written in terms of log 10. At 298 Kelvin, this equation can be simplified, which 2.303 times R and T over F is 0.0592. Let's write Nernst equation in this example, reaction between manganese and argon term. As standard reduction potential of argon term more positive than manganese, argon term undergoes reduction and it is cathode, while manganese is anode and undergoes oxidation. So this is overall equation. Since reaction quotient is molarity manganese 2 ion over molarity argon term ion powered by 2, therefore Nernst equation for this reaction is shown here. Now we have arrived at the last part of this video, which is factors affecting cell potential. Let's take zinc copper half cell as example. This is Nernst equation for this cell. The cell potential can be increased if the standard cell potential greater. The standard cell potential can be increased by two ways. First, use cathode with more positive standard cell potential. Argon term half cell can be used to replace copper half cell because it has more positive standard cell potential. Second way is use anode with more negative standard cell potential. Aluminium, for example, can be used to replace zinc as anode since it has more negative standard cell potential. The next factor is concentration of reactant and product. If copper 2 ion concentration increase or zinc 2 ion concentration decrease, reaction will occur in the forward reaction. Thus, cell potential increase. And lastly is temperature. When temperature decrease, the value of the whole part of this Nernst equation also decrease. Thus, standard cell potential minus with smaller number. So, cell potential value greater. This is the 5 factors affecting cell potential. Number 1, standard cell potential. As standard cell potential increase, cell potential increase. Number 2, use cathode with more positive standard cell potential or use anode with more negative cell potential. Number 3, increase reactant concentration. Number 4, decrease product concentration. And number 5, decrease temperature. We are at the end of the video. Thanks for watching.